Least common multiple. Now, least common multiple can almost be viewed as something entirely different than GCF. See, factors are what? What do we say factors were? Yes? Not add up. The numbers we multiply together to get our product, or the answer we multiply. Those are factors, okay? Now, multiples are what we get. Multiples focus more on the product itself. So if I were to say, let's use the number 10. Factors of 10. Numbers that we use to multiply together to get 10. So you say, okay, 1 times 10, 2 times 5. Any other factors? So 1, 2, 5, and 10. Now, multiples of 10. How are they different? What is the first multiple of 10? Bessie, what is that multiple? 10. Next multiple of 10.
20. Oh,
okay. Those are multiples. So if you look, the largest factor of 10 is what? The largest factor is 10. The smallest multiple of 10 is 10. Okay? So your factors can only be so big. They cap off at whatever that number is. The largest factor of 100 is what? 100. The largest factor of 1 million is what? Okay. The largest multiple of 100 is what? It's hard to say. Can it go on and on and on?
Yes.
So it's actually a good thing that they ask you for the least common multiple instead of the greatest common multiple. Can you imagine how long it would take to find the greatest common multiple between two numbers? It can go on forever. So they want to know the smallest multiple they'll have in common. Now the method itself starts similarly to the way that the factors do. With the factors, remember, we looked for what they had in common. Multiples, we're going to look for what they have that's different. So if we take a look at, well, let's use something real simple. Let's start with 4 and 5. So we're going to start with 4 and 5, and we're going to find the prime factorization of a 4 and the prime factorization of a 5. Okay? So let's go for it, and we'll say 4 is easy. That's 2 times 2. And the other thing we're going to do is, for GCF, we listed out the factors. Let's go back now and put them into exponents. So we won't say 2 times 2 down here. We'll say 2 to the second power. Now let's go to the 5. 1 times 5. Okay? Any questions so far on what we just did? We have not found LCM yet. Yeah? Yeah, you'll still use your list for the prime factorization. Okay. If you don't have a lot of them memorized already. Okay? Now, when I want to look at what's different, I'm going to then focus on that. Now, I can only use each factor one time. So I'm not going to bother with this 1. Why? When I multiply anything by 1, it's going to remain the same. So let's take this 2 to the second power. And yes, I'm taking it to the second power. And let's also take that 5. 2 to the second power is 4. Times 5 is 20. 20 is going to be your least common multiple. And yeah, if you think about it, if I were to do it the old-fashioned way, the way I learned it as a kid, that's pretty old, pretty long time ago. They encourage you to list the multiples. So 4, 8, 12, 16, 20. Okay? Fine. It's again, it's a little bit old and it's flawed. And then the 5s. 5, 10, 15, 20, 25. And then it says, okay, well, find the first multiple that they have in common, and you can circle the 20. Okay? Now, the issue with this is if you make a mistake somewhere along the line in making your list, you may go on forever and never find it. And you say, well, that's easy. I'm just working with a 4 and a 5. Okay, fine, I get it. But what are you going to do when you're working with a 16 and an 18 or something? Do you know your 16s that well that you can go 5, 6, 7, 8 deep? Or your 18s that well where you can just... Very easy to make a mistake. I mean, the method that we use here, it takes a little bit of getting used to, but once you understand the concept, I think it's much easier. Okay? If you want to make it harder in your head, that's the decision you're making. Okay? Let's try another one. Let's go with... Let's go with a 6 and a 14. Prime factorization for a 6. And those are both on my list. Prime factorization for a 14. Larissa. Sure, 2 times 7, 7 times 2. Okay, now I want to make sure everyone is seeing this because this is something that you want to be aware of. For LCM, I'm not focusing so much on what they have in common as far as factors. I'm looking to see what they have that's different. But you will come across a situation where you will get some that are the same. I have a 2 here for the 6. I have a 2 here for the 14. I can only use one of these 2's. Are either of these 2's larger in value than the other? No. So what I'm going to do is I'm just going to pick one. I'll pick this top one, and then I'm going to cross out the other one. I'm not going to use that one. So I'm going to pick that 2. Then what's next? The 3. And finally, 7. Now remember, they don't have to have these in common. That's why I can use the 3 and the 7 especially. Multiply them out. 2 times 3 is 6. Times 7 is 42. 42 is your least common multiple. Larissa. You'll have to pick between, you can only use one of them. And you'll always use the one that's greater in value. We said that neither one of these were greater in value. And what I mean by that is sometimes, Dakayla, you'll have a regular 2, and maybe you'll have like 2 to the 3rd power. Which one are you going to use? 2 to the 3rd power, because it's the larger one. Okay? When they're the same, just pick one and cross out the other. Okay? But if there's a larger value, we're going to use that one. Okay? So let's try, you try one. 16 and 6. Told you this is a little bit of a complicated process if you're not understanding what's really going on. So let's do the factor trees together. And for 16, we get 2 times 8. 8 is our, okay. Now again, I will encourage you, when working with LCM, to use the exponent form. I have 4 2's, which means, okay, it'll be clearer if you do it that way, trust me. And then 6 is just a simple 2 and a 3. Okay, now watch carefully. I have a 2 to the 4th and a regular old 2. I can only pick one, and I have to pick the one that's bigger. That's Rihanna. So I'm going to circle this 2 to the 4th. I'm going to cross out this other one. What else? Is there any other 3 to choose from? So that's the one I'm stuck with. Okay. Now, so a lot of people with 24. No, 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 no. 2 to the 4th is not 2 times 4. Besides, what did you just tell me 2 to the 4th was? It's 16. You just told me that. You told yourself that. So 16 times 3 is 48. So that's how close some of you were. Some of you had those 4 2's, and you multiplied it to the 3. You just didn't do it right. You were that close. Maya. Yep, you got to keep going and see what else is different. Yes. All right. For the factors that are the same, like the 2 and the 2, you pick the one that's bigger, and then you're looking at other ones that are different. If they're the same, you pick the one that's bigger. Yes?
I got 48, but I did 2 times 3 times 8.
You didn't break down the 8. You lucked out. 8 shouldn't be at the bottom. When you're done with your prime factorization, the only thing that should be at the bottom here, Liam, are prime numbers. If it's an 8 up here, that means you didn't break it down like you should have.
Okay, we're supposed to break it down like
You break it down as much as you possibly can until you get to prime numbers. Casimir. Did you get this part? Did you get the 2 to the 4th and then the 2 times 3? So you got to get that part right before you can really truly understand what it is. Let's try another one. Okay? Let's try a 12 and a 16. Okay, here we go. 12 is 4 times 3. So 2 to the 2nd power times the 3. Well, we just did 16, right? That was 8 times 2. So 2 to the 4th power. Now, comparing between a 2 squared and a 2 to the 4th, because they're both 2's, which one am I going to use? Which one's bigger? 2 to the 4th, let's cross out that 2 squared. What's left? Now, listen carefully, please. If you are not making this connection, and if you are confusing it by saying that 2 to the 4th is 2 times 4, you can always rewrite it out the long way and take it piece by piece. 2 times 2, 4, 4, just like the other one. 16 times 3, it's still going to be a 48. Yes, sir. You what? my sink. Here we go. Try another one. We're going to bring back the 16. 36. Now, we can already put down for 16 the 2 to the 4th. Again, you know, those are some of the connections that hopefully you make the more you do this. Like, okay, we've made our connection with the 3-headed monster, the 8 that is 2 to the 3rd, the 16 is 2 to the 4th. 36, 6 times 6. Bottom line, I have 2 2s and 2 3s. Okay? 2 2s, 2 3s for 36. Okay? So, when I look at my 2, I've got 2 to the 4th and 2 to the 2nd. Which one's bigger? So I'm going to use the 2 to the 4th, cross out the 2 squared. What's left? Okay. Now, we know that 2 to the 4th is 16. What's 3 to the 2nd? 9. Not 6, but 9. 16 times 9? Close. 144. Now here, I'll show you why you would rather do this method than the other. Because now I'm going to have to list all these factors of each and try to match up with 44. This method works okay when you have smaller numbers. When you have larger numbers, much easier to do it the way that we're showing. It is. Talk about a 3-headed monster. Casimir? Huh? Can I put 2 to the 4th power where? For 16? What is 2 to the 4th power the long way? And if I go piece by piece, Casimir, you're watching? 2 times 2 is 4. Times 4. What's 4 times 4? There it is. That's why it's 2 to the 4th. Now, 5. Prime. 1 times 5. 6. 2 times 3. 10. 2 times 5. Now, 1. Let's just cross that 1 out, right? That's not going to make any difference. So now let's look at the 2's. I've got a 2 and a 2. Is one bigger than the other one?
No.
So I'm going to pick one, cross out the other one. I've got a 3. Do I have any other 3's to pick from? I've got a 5 and a 5. Cross one out, right? 2 times 3 is 6, times 5 is... This part down here, 6th grade, is very important. As we're crossing things out and circling things and keeping track of what it is that we have, what we're choosing from, it's much easier if you actually do that work. Yes, ma'am? If there's a 1 there, it's, if we were to use that, Desriana, and I put that in front, is that going to change our 30? No. So that's why you don't necessarily need it. Okay? Are you ready? You want this? You ready for this? Let's do one that doesn't have a 16.
Let's do it. Does have 16. Let's do live. Let's do 36.
Okay, for 28. For 28, I can pick 2 times 14. That would be perfectly fine. But don't lose track of this, please. That's prime. No longer able to be broken down. Then we break down the 14, 2, and 7. I'm now finished with the 28. 2 squared times 7. 42. I can go 2 times 21 if I want, unless I want to go 6 times 7. Either way. And then for 42, 2 times 3 times 7. Between a 2 squared and a regular 2, which one am I picking, Alexis? And let's get rid of that regular 2. There's the only 3 that I have. And between a 7 and a 7, which one? Either one I want, right? So I'll cross that one out. I'll pick that one. 2 squared is 4 times 3 times 7. 4 times 3 is 12. 12 times 7? 84. Yes. Yep.